Selection sort builds the sorted list one value at a time. Each pass finds the smallest value in the unsorted part. Then it swaps that smallest value to the front. Repeat. And the sorted region grows from the left. It makes fewer swaps than bubble sort. Here is selection sort written in Python. N is how many items the list holds. The outer loop picks each position to fill. We assume that position already holds the minimum. The inner loop scans the rest for anything smaller. If we find a smaller value, we remember its index. After scanning, we swap the smallest into place. Now let us sort 5, 2, 8, 1, 4 by hand. Pass 1. Assume position 0 holds the smallest. Compare 2 and 5. Smaller, min moves. Compare 8 and 2. Not smaller, keep. Compare 1 and 2. Smaller, min moves. Compare 4 and 1. Not smaller, keep. Swap 1 into position 0 and lock it in. Pass 2. Assume position 1 holds the smallest. Compare 8 and 2. Not smaller, keep. Compare 5 and 2. Not smaller, keep. Compare 4 and 2. Not smaller, keep. 2 is already smallest, so it locks in place. Pass 3. Assume position 2 holds the smallest. Compare 5 and 8. Smaller, min moves. Compare 4 and 5. Smaller, min moves. Swap 4 into position 2 and lock it in. Pass 4. Assume position 3 holds the smallest. Compare 8 and 5. Not smaller, keep. 5 is already smallest, so it locks in place. The list is now fully sorted. 1, 2, 4, 5, 8. So how fast is selection sort? Each pass scans one fewer item than the last. That is 4 plus 3 plus 2 plus 1, which is about n squared over 2 comparisons. So selection sort also runs in order n squared time, but it makes at most n minus 1 swaps. In short, pick the smallest, move it to the front. It does the same work even on a sorted list. Handy when swapping items is expensive. If this helped, please subscribe to the series and comment which algorithm we should cover next.